In this lesson, we're going to apply the Pythagorean theorem on the coordinate plane by finding the distance between 2 points. Then we're going to learn how to find the distance between two coordinates without the coordinate plane using the distance formula. So here we're being asked to find the distance between -6, -2, we'll call that point A, and -1, 5, we'll call that point B. Now, because this is on a diagonal, we can't just count the units because it's not going through each unit at exactly 1 unit each. So what we're going to do is we are going to create a right angle by plotting a third point. We can either plot it here or we can plot it here. I'll go ahead and just plot it right here. So when we plot this third point, we're creating the legs. So when I connect A to, we'll call C, we have a leg of 1, 2, 3, 4, 5 units long. And then we have from B to C is 1, 2, 3, 4, 5, 6, 7 units. So from A to C was our horizontal leg, which was from -6 to -1, a distance of 5. Then when we connected B to C, this was our vertical leg, and we connected from 5 down to -2, which was a distance of 7 units. So when we connect our two legs, we have a vertical leg and a horizontal leg. So we have the change of the x coordinates and we have the change of the y coordinates. So the change you can see here from -6 to -1, when we take the difference, we get a length of 5. And then from -2 to 5, when we subtract those, we get a distance of 7. So now let's let 5 be our A and 7 be our B, and we're just plugging it into the Pythagorean theorem, which is A squared plus B squared equals C squared. So now we just do the math. We combine 25 plus 49. We undo the squaring by taking the square root. And C is going to be about, I'm going to take our calculator, and it's going to be about 8.6. So our hypotenuse, AB, is about 8.6 units. Here's another example. So we have 3, -5, and then we have -4, 1, and we want to know the distance between these 2 points. So we're going to make a third point, creating a right angle, and our vertical leg is going to be 1, 2, 3, 4, 5, 6 units. Our horizontal, the difference of our x values, -4 to 3, is a distance of 1, 2, 3, 4, 5, 6, 7. So we have leg A, we'll call 6. Leg B is 7. We square these, we combine these, and then we solve for C, and we take the square root of both sides. So now I have C is equal to about 9.2 units. It's not exactly, but it's about 9.2. And maybe we should change colors so we can see that, 9.2 units. And remember, your hypotenuse is going to be the longest length, always. Okay, now we're going to plot 0, 3, a y-intercept, and an x-intercept, 6, 0. And then I'm going to plot at the origin, and we're going to have our diagonal. That's the distance we're finding. So we have a vertical leg that is 3 units and a horizontal leg that is 6 units. So we have 3 squared plus 6 squared equals c squared. And we're solving for c, the distance from A to B, our hypotenuse. So c is going to be about 6.7 units. Let's try one more. And this time we're going to notice the 2 points, and let's try to do it without the graph at first and then prove. So I want to change so we can see this. So from -4 to -1 is a difference, or the distance between the two is 3 units. Then the vertical is going to be from 6 to 1, there's a distance of 5. So our legs should be 3 and 5. But let's prove this. So -4, 6, and then we have -1, 1, and here is the diagonal. So our third point will be here, and the horizontal leg is 3, we got that. And then the vertical leg is 5 units. So this is how we're going to do it in just a minute when we don't have a graph. So let's square our legs. Let's combine them together and then take the square root to isolate. So C is going to be almost 6, but not quite. It is going to be 5.8. Okay, so here is the distance formula. You may want to pause this and write this in your notes. And you can just totally, so remember from slope, this would be x1, this is y1, this would be x2, and this is y2. So I'm going to show you directly using the formula. So D, the distance between the 2 points. So we're going to have 2 minus 8, so that's going to be the distance between the horizontal leg, and then we'll square because that's what the Pythagorean theorem says. Then we will have the vertical distance from -6, and we subtract to find a distance, and we square that. So 2 minus 8 is -6, but once we square it, we get a positive, which we always will. Here, when we combine these, we get -6 minus 3 is -9, and we square it. And then we add these together, and then we're going to take the square root. And we get about 10.8. Now, let me show you how we can do it like we did here without the formula. And this may make a little bit more sense. So if I'm going from 8 to 2, the distance between 8 and 2 horizontally, so just envision the horizontal number line, is a distance of 6. Then our vertical, it's vertical because we're talking about the y's, the distance between 3 and -6. So just envision on the vertical number line, you're at 3 and you're going all the way down to -6. That is a distance of 9 units. And this is where we have the 36 because we squared 6, and we have the 81 because we squared 9. So if you do not like using the formula, the distance formula, you can just simply know that 6 is the horizontal leg, 9 is the vertical leg, and just plug it into the more familiar formula. And we're going to get the same thing. and we get 10.8. So if you like to use the formula, you can use it. Just be very careful plugging in. This is x1, this is y1. This is our second coordinate. I'm simply going to find the distance, the horizontal leg, because we're dealing with x's. So the x coordinates, and I'm envisioning -4 on the horizontal number line, and I'm at -4, and I'm going all the way to +6. So from -4 to 6 is going to be a distance of 10. So that's going to be my horizontal leg. Then I'm at -1 on the vertical number line, and I'm going down to -9, and that is a distance of 8. So I have 10 squared plus 8 squared equals c squared. I'm going to take the square root and see the distance between these two coordinates on the coordinate plane is about 12.8. Let's do one more. So my horizontal distance, my horizontal leg, so this is x1 and x2. So the distance between -8 and 2 is 10 units. Then we have the vertical leg. So from 5 to -4, so I'm at 5 on the number line on the y-axis, and I'm 5, and I go all the way down to -4. That is a distance of 9 units. So I have 10 squared plus 9 squared equals c squared. I take the square root to solve, and the square root of 181 is approximately 13.5. And again, if you like to use the distance formula, then by all means use that. I hope this helps.